Okay, today's lesson is really day 3 on factoring. We've talked about factoring so far as like reverse distribution, trying to factor out one monomial. Again, taking out something that divides every one of the terms, and that's a way to help factor. And we started factoring a trinomial into two binomials. It's kind of a short lesson here, but showing where we're going with all this. Again, we're trying to get to the point where you're going to use these techniques to help us solve a quadratic equation. So when there's something that sets up with a quadratic, we can use this technique to find the answer. Okay. First, remember that when we talk about factoring, what we're trying to do, factoring means breaking something apart into looking at the factors of it, breaking it apart into the things that multiply up to that. We started with a number, first of all, like 28. And we said, well, 28 can break into, really, it's 4 times 7. Those are factors of 28. So this is called factoring. And then I can even break something apart even more sometimes. Like I factor the 4 into 2 times 2. So really 28 breaks all the way down into these three things that are multiplied up to get me to 28. And again, forever we've gone this direction. And now, okay, we're starting to figure out to go this way. And we're doing it with algebra, with quadratic. So think about the things we've done the last couple lessons here. Let's start with this problem right here. When we factor, we're breaking this apart into all the things that multiply up to get to that point. So the first way we should look to factor is the first one we learned. If I can, I should see if there's something that I can divide out of each of these three terms. That's a good way to start these problems where I want to factor something. And again, I want to factor it completely as much as I can. There may be a couple ways I can break it down. So first, taking a look at this problem, looking at the numbers just themselves, let's start with the numbers. I think all those numbers are divisible by 3. So I can factor out a 3 from this trinomial. And when I do that, what I'll have left in the parentheses is x squared plus 7x minus, a little math here quick, 18, I believe. Okay? So 3 times x squared plus 7x minus 18. Now, okay, that's us again factoring, just like we did 28 above, we factored a 4 and 7. But if you look carefully, we've learned also just recently how to factor trinomials. And look at that trinomial, this actually will factor into two binomials. Okay? Now just like above, the 3 is still going to, like something that still multiplies up to get to the original still stays in the problem. So that 3 is going to come down like I draw it there. That's still in front. But I'm going to now break this trinomial down into two binomials like we've done in the last couple lessons. X squared here, so my two binomials start off with x and x. When I'm looking at that last constant, it's negative 18. So remind you some of those things that tells us is that the two signs in here are going to be a plus and a minus. I'm going to have one of each because I got to multiply two things together to get me negative 18. Okay, factors of 18 are 1 and 18, 2 and 9, and 3 and 6. And since I need to get negative 18, right, my rules told me that I need two factors that have a difference of this middle number, which is 7. So 2 and 9 are the combination that I want. And I need to get positive 7, right? So the 9 needs to be the positive one, and the 2 needs to be the negative one. So factoring this trinomial gets me all the way down to this. These three things multiplied back together will give me the original trinomial, okay? And I could see that where if I did FOIL method with these two binomials, what do you know? I would just get what I have above. And then if I just distributed the 3 to everything, I would get the top line. So again, you can see how I can work one way, one direction, and the other direction. But if I'm factoring, I'm going down to this. Okay? Let's look at another one here that I've got. So again, we're going to factor now, the directions would say. Going backwards from ways that we've done all these chapters up before this. Okay, now I'm factoring. I'm trying to break this apart. And again, next I'll show you how we're getting to something that will help solve an equation for us. Okay? So take a look at the first way you should look to factor any kind of trinomial is, can I first factor something out of each of these terms? And yes, I think we can. Not only a number, but a variable. 2x to the third minus 28x squared plus 48x. All those terms are divisible by 2. So I'm going to pull out a 2, and they all have an x, at least one x in common, right? So I'm going to factor the 2x for this trinomial. When I do that, I should be left with x squared for the first term, 14x for the middle term, and 24 for the last term. So I factored out the 2x, and here's what I have left for my trinomial. Good. Now, again, like we talked about, That is always, as we go forward in this chapter and as you go forward in these things, you should look to do something like that first. Factor out a monomial if you can. Then look and see, okay, can I do some more factoring with that trinomial? And I bet that we will be able to here in a second. So I'm going to leave the 2x. I'm going to bring that down, though, because that's still important. That's still part of what gets multiplied back to get to the original. So that, yes, that needs to come with. If you don't include that in your answers, I will mark that wrong. Okay, that needs to be part of it. So 2x needs to be out front. I'm going to make 2 sets of parentheses again, and I'm going to see if this factors nicely, and I think it will. X squared means this comes from x and x. Looking at my last number there, positive 24. Let me start with writing the factors right now. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Bunch of different combinations. The positive sign here, the positive sign tells me that the signs are going to be the same for both my binomials. And since I need to get to negative 14, that means both the signs must be adding 2 negatives together to get to negative 14. Since the signs have to be the same thing. So 2 factors that add together to be 14, I believe that's going to be 2 and 12. So there's me factoring that trinomial. I get all the way down to 2x times the binomial x minus 2 times the binomial x minus 12. Okay, so again, going off that first slide now, I've just copied that last problem we just did, and I brought our answer on over. Remember, we factored this just a second ago to 2x times x minus 2 to x minus 12, okay? So where are we going with this? How is this going to help us solve problems in this future, this factoring that we're doing, okay? Well, in the future, okay, very soon, really, very near future, you're going to have problems just like we just did. 2x to the third minus 28x squared plus 48x, but it's going to be an equation, and it's all going to equal 0. We're going to find out. To solve quadratic equations, okay, this is actually what we want to get to. We want to get the whole equation equal to 0. That's important. That's going to be one good way we can solve them. When we solve linears, you try to get x by itself, but for these, this is actually the setup we want. And we want that because look at what we have on the left side now. This is like our trinomial we just factored. So I'm going to zoom ahead and realize that, remember, this is what we get when we factor this. Okay, we'll do a problem like this, and we'll factor it, and we'll get 2x times x minus 2 times x minus 12. Doing all the steps we just did, but I'm fast forwarding to the new part here. Now I'm solving an equation, okay? Here's where we get our solutions for this problem. Okay, remember again, for linears in the past, we'd get something like x equals 3. Like, that's how we find the answer to the problem. That's the number that makes the equation true. Okay, well, with quadratics, that's still what we're trying to do. We're trying to solve the problem. We're trying to find out what values of x will make this equation true, okay? To do that, take a look at, I'm going to start with one of the binomials first, actually the last one, okay? Look at what's happening in this, what we factored now for this polynomial, right? I have this 2x, this monomial out here, 2x, okay? And that's times x minus 2, and that's times x minus 12. All 3 of these things are multiplied together, right? This is times this, oops, this is times this, and this is times this. Everything's multiplied together, okay? Well, what we know about this equation is it's saying that all those things multiplied together, when I multiply 3 numbers together, the answer's got to be 0. There's a property called the zero product property that's going to help us out. And if you think about it, it makes sense, right? If I tell you that you're going to multiply 3 numbers together, these 3 numbers together, and it's got to be, the answer has to be 0, what does that tell you? That tells you that one of these numbers, either this one, or this one, or this one, has to be 0 for this equation to equal 0, for it to be true, okay? So what we do to solve a quadratic equation, then, is we think of what x could be, just like we do in other equations. What could x be that would make one of these things 0? Let's start with this one over here, okay? Look at this binomial. What could I put into x? Minus 12 from it, and that would make this binomial right here 0. Well, there's only one number, right? 12. If I put 12 in here, 12 minus 12 would make 0. So that's one of our solutions. Okay, this is how we solve a quadratic. We break it down into this factored form, and then I look at each binomial and I say, okay, what would make this binomial 0? Well, 12. If I put 12 in there, 12 minus 12 would be 0 like we have, and 0 times whatever these other two would be, it wouldn't matter because 0 times anything is 0. So that would work. 12 would be a solution. Okay. Now let's look at this binomial. We look at all the cases. Okay. What could I put in for x in this binomial that would make it equal to 0? Well, 2. 2 is the answer that would work, right? Because if I put 2 in right here for x, okay, I put it in for all the x's, but if I put it in here, 2 minus 2 makes 0. So then this binomial would be 0, and times it by anything else would make the whole thing equal to 0, and that's what I'm saying the equation has to be, 0, okay? Good, the last one sometimes is the trickiest one, okay, but look at that very first one, okay? What could I put into x to make that part of it 0? And some people have to think for a second, or they think like negative numbers, or nope, what times 2 will get 0? Well, it's just 0 itself, so there's my third solution. If I put 0 in for this x, 2 times 0 will be 0, and timesing it by whatever the other ones would be would also be 0. So there's the 3 possible answers for this particular quadratic equation. Okay, I break it down to that factored form, and then I find what values of x would make the equation true. What ones will make it equal 0? Just to have one more example of this to show you, let's go back to the very first problem we did in this video. We factored this trinomial right here, right? We took out a 3, and then we factored it down to the 2 binomials, and again, just kind of skipping ahead to the crucial part here, but we factored out a 3 first, and then when we factored this into 2 binomials, we found out that it was going to be x plus 9 and x minus 2. So here was our answer from the first page. But now, let's say it's an equation where it's all equals 0. So we're trying to solve this now. Solve it. What values of x will make this equation true? And when we have it in this factored form, as we've been practicing, now we can solve it and figure out what values of x will make this whole thing equal 0. Okay, well, again, where that comes from, first I'm going to put x equals down here. But where those answers come from is look at the 2 binomials we have, okay? So in this case, we have 2 places where I see x, here and here. So I got to think of what values of x will work. Well, what value of x will work in this binomial? Because this is all multiplied together, right? It's this times this times this. It all equals 0 somehow. Well, what value of x could I plug in here that will make this binomial equal to 0? Well, the answer ends up being negative 9, right? Because negative 9 plus 9 would give me 0 for that binomial. And then when I times it by 3, it's still 0. And I times it by whatever this is, it'll still be 0. And so that will equal 0. So negative 9 is one of the answers, okay? Look at the other binomial for my other option, x minus 2. So what number could go in for x so that this would end up equaling 0? Well, that has to be positive 2, because a positive 2 minus 2 would give me 0 for this binomial. And then timesing it by this and timesing it by 3, whatever those would be, those would also make it equal to 0. Okay, so those are my 2 answers. Now again, we'll learn more of this, but why isn't there a third answer like there was in the problem above? Well, that's because take a look at the very front. In this case, I don't have x up here, right? It's just 3 by itself right here. So there's not a place to put a number in for a variable. There's no x. So in this case, I just have 2 places where I can put x in. This x and this x. That's why I just get the 2 answers, okay? Another way we'll see that in the future is just look at the degree of the polynomial. So since the highest degree is 2, there'll be 2 answers. And these are my 2 answers for that one. So there's just a little taste of what we're getting into now as we factor and we take it into solving quadratic equations.